Before running an FDTD simulation, one first needs to define the structure that is to be simulated. So this is done through the structure design tool. When we open the window, we have on the left the different geometric operations that are going to apply to our structure, and on the right, a 3D view of the structure itself. First, at the top left, we have the different sizes of the window that we want to simulate. So in this case, my computational window is 300 nanometer wide in every direction. If I wanted to change this, I would just need to change this value. And in this case, it's only 100 nanometers long along X. So I'm going to set it back to 300. Now, once this has been defined, we can add geometric operations. So let's say, for instance, I'm going to add a layer to make the substrate, and I'm going to add it. So we don't see anything because it has a thickness of 0. In this case, the first parameter here is the bottom of the layer, and the second is the top. So I'm going to set this to 100 nanometers. And then we have an index that is a reference to the material number. So the structure is going to be defined using those indexes that are going to point to a specific material. In this case, the default material, that is the environment, is index 0, but my layer is also index 0. So in the FDTD computation, they're going to refer to both the same material. So to make it have a different material, I'm going to set the index here to 1. I can add a new operation, so let's say a sphere that is going to be a particle, and I'm going to place it at the center of my window, so 150 nanometers, 150, and the Z value is going to be, for instance, 200 nanometers with a radius of 100 nanometers. And we can see our particle. I'm going to give it a material index 2, and that's basically it, except that in our case, the top of the particle is exactly at the top of the window, so we don't want that, so I'm going to extend the window a bit, and we have our structure that we want to simulate. I can click on the autocolor button to better see what I'm doing, but I can also move this particle. So for instance, if I were to switch it to 150 nanometers, so in this case, while it seems that we only have part of the sphere, we actually have the full sphere in the mesh instancing, because the different operations are applied in the order they are defined. That means that in this case, we would first have the ambient material of index 0 everywhere, then we will define in this region only the substrate with material 1, and above it, we would define the sphere, but in this area, the sphere would actually overwrite the layer. So we would actually have, in this case, a sphere that is embedded inside the substrate. So the order matters a lot. For instance, if I were to switch the operation order, in this case, the sphere would be defined first and then the substrate. In this case, my sphere will be cut or overwritten by the substrate, and the true structure would look like this. Once this is done, we can then save this. So, for instance, I'm going to call this sphere, and we have our structure in the relevant directory.